All right, everybody, here's our little screencast guide to assignment 6.10, Empirical Formula Lab. So right now you should have a green sheet of paper, which is kind of an old lab sheet that I had given out when we had done this lab in the past. Has a lot of information on it, talking about empirical formula and this idea of the law of definite proportions. Just saying that when you have a specific atom to atom ratio, you're also going to have a specific mass to mass ratio. Now, the atom to atom ratio has to be in whole numbers. The mass to mass ratio does not. And again, that's because different particles weigh different amounts. So in addition to the green sheet, you should also have a Chromebook pulled up, which is open to assignment 6.10 in Schoology, where you're going to find a lab template. And in that lab template, I've set up the different sections that you're responsible for putting information into. You just need to start putting some of that information in. So first bit of information is I'm giving you the researchable question. This is what we're trying to figure out. Based on data that we collect, what is the mass to mass ratio and empirical formula for the compound formed when magnesium and oxygen combine? So you're going to take magnesium metal, you're going to heat it up, you're going to give it enough energy to where when it combines with oxygen atoms, they have enough energy to be able to form bonds and make a compound. So that is your researchable question. You go ahead and copy that down into that spot on the lab template. Then what I want you to do is take a couple minutes and go into what you know about the periodic table, charges, masses, things like that, and make your prediction. What is the mass to mass ratio going to be for this compound, for magnesium to oxygen, and what is the empirical formula going to be for this magnesium and oxygen combination to make the compound? Then take a minute and create a data table. You can just copy the one straight from the bottom of the green sheet into your results section. Now, that's not the only thing that's going to go into your results section, but that's a great place to start, and you can paraphrase it and make it make sense to you. Please pay attention to the last two columns that are said that you're going to calculate those. You're not actually going to measure the magnesium oxide or the oxygen. Oxygen you can't really measure, right? It's a gas flying all over, but magnesium oxide, some of it gets stuck inside the crucible. So we have to do that indirectly to be able to make that measurement. We'll talk about that more here in just a little bit. Okay, right now the equipment is all sitting, it's either out on the benches or it's still sitting over on the cart in the room. When you get ready to get set up, this is what you need. You need a pair of tongs, you need a Bunsen burner, you need a ring stand with the ring, you need one of these clay triangles, and you need a crucible. The crucible is a little cup. Clay triangle goes on the ring. That's on the ring stand, Bunsen burner, tongs. So that every group needs this equipment for their setup. Now, each lab bench can have up to 2 groups working at once. It'll look kind of like this when everything is up and ready to go. So make sure that when you attach the hose to the gas nozzle that you push it on there good, so we don't get any gas leaking out. Now, middle lab bench is off limits to Bunsen burners, partly because the gas jets don't work and partly because I need a place to be able to put all the balances. So in the middle, you're going to have the electronic balances, rulers, scissors, and then the magnesium. Now, when you first get started and you're ready to go, you're going to cut off a 3.5 centimeter piece of magnesium. Make sure you're using centimeters, not inches. And then you're going to go ahead and get the mass of that and record it. So that's all taking place in this center bench area. Now, once you have your magnesium and you've gotten the mass of that, take a crucible, wipe it out with a paper towel, dry paper towel, just to get any extra chunks out of it. Coil your magnesium so that it lays flat on the bottom of the crucible, but you don't want parts of the magnesium touching because that's going to be spots where the oxygen can't get to. We need this whole thing exposed to be able to have the oxygen atoms combine with as many of the magnesium atoms as we can get. So you want to make sure that you leave that open. So you're going to coil it so that it lays flat, because if it doesn't lay flat, it won't heat up enough, but not so tightly that you have pieces of the magnesium touching each other. This is seems kind of silly, but it won't work correctly if you don't have it setting kind of like what we have here. Right? So now you're ready to go ahead. You have the mass of your empty crucible. You have the mass of the magnesium by itself. You have the mass of the two together. You're ready to go ahead and start heating. So We're going to return to our lab bench. You're going to go ahead and put your crucible in your clay triangle. Make sure that your Bunsen burner is underneath it. Then ask Mr. Isaacs to go ahead and come by and get the Bunsen burner going for you. If you get your Bunsen burner going and either the flames going out over the sides and coming out the top because the Bunsen burner or the crucible is too low, or the flame stops like clear down here and it's not even close, move the Bunsen burner out from underneath there and then loosen that, and you can very gently raise that up or lower it. Now you want the bottom of the crucible to be right at the top of the inner blue cone of the flame. We want to heat this baby up as fast as we possibly can. And so once you have that set and you're heating it, you're going to watch for it to glow inside. It usually takes between 2 to 4 minutes. If after 4 minutes it's not glowing, you need to kind of reassess what you got going on there. Either your flame's not heating enough or your magnesium is not touching the bottom enough. You have to kind of fix that. But as soon as it glows and you see like a little bit of smoke coming out of there, go ahead and start your timer and then heat that for an additional 4 minutes. We want to make sure we allow all of the magnesium a chance to react. And then as soon as that 4 minutes is up, you're going to go ahead and shut the gas off. So you just push the valve until it stops, and then the flame goes down and will go out. Then you're going to leave that to cool, and you're going to head back to your desks, and you can go ahead and work on copying a procedure into the lab template. And then you can also work on any other of the questions from assignment 6.9 that you didn't do from the other day, from the worksheet from Tuesday. So that's a paper worksheet you can work on. About 15 minutes or so should be enough time for this to cool down, enough for you to be able to take it and put it on the balance and get that final mass that you need. Now, this is what it should look like inside when it's all done. If you don't have something that looks like this, like essentially like it burned, right? Like you know, like an ash, then something's not right. So this is what you're looking for afterwards. Now, this is the magnesium oxide. We've taken magnesium, we've added oxygen to it. So you have to do some subtraction action to be able to figure out the mass of this, because we're not going to just pour this onto the lab bench because some of it gets stuck in the crucible. You're also then going to have to subtract a little bit to figure out the mass of the oxygen that got added to this. So I think that's about it. When you're all done and everything's cooled off and you've had this weighed, just dump the contents of the magnesium oxide into the trash can and put everything back on the benches. I think that's about it. Thanks, and have a fantastic day.